In the second part of the video, we will be adding and subtracting rational expressions that have different denominators. And of course, that makes our work a bit harder because you have to find the least common denominator in order to add fractions that have different denominators. And of course, we're going to say LCD instead of least common denominator, a little bit long. Before we start adding and subtracting these fractions that have different denominators, we need to practice how to find that LCD. We need to factor each denominator, write down one of every kind of factor that you have, and then raise each factor to its highest power. So these first two problems, we're not going to add or subtract. We're just going to find the least common denominator. So we look at step one, factor. Well, there's really nothing to factor because these are monomials, but we can write down one of every kind of factor. So the LCD equals, remember factors are things that are multiplied together. So here we have A multiplied to B multiplied to C. So the factors here are A, B, and C. Here we have A, B, C, D. So since I want one of every kind of factor, we have to put the D as well. Then we want to raise each factor to its highest power. So let's look at A. The highest power is a 2, so I'm going to put a 2, or A squared. On B, the highest power is a 4, so I want B to the 4th. C, the highest power is a 5, so I want C to the 5th. And since there's only a D to the 1st, then we keep a D to the 1st. And that's our least common denominator for those two fractions. Let's look at this next one. Well, 6 and 4. You should know the least common denominator, as in what's the smallest multiple they have in common. 12. So the least common denominator is 12. That takes care of the 6 and the 4. And since the other factors are an x and a y, we write that down. And then we want it to the highest power. So we have 3 and 2. Highest power would be 3 on the x, and then the y, the highest power, is 5. So this LCD, least common denominator, would be 12x cubed y to the 5th power. So now we're going to start adding and subtracting these rational expressions that have different denominators. So the process is find the LCD, rewrite each fraction with that LCD, then we collect like terms of the numerators, reduce if possible. So here are our two fractions. What would be that LCD? Well, we have to have the 8, and then we have to have the x. Those are the two factors. And then we want to raise the factor to the highest power, so we would have x cubed. So 8x cubed is my least common denominator. So I'm going to write this where I have a little bit more space. And I suggest you do the same. So I want to write each of these with 8x cubed being the denominator. So let's look. The question you have to ask yourself is, what do you have to multiply this old denominator to make that new one? And of course you'd have to multiply by 8. And whatever you multiply by on the bottom, you have to multiply by on the top, because 8 divided by 8 is 1, so you're essentially multiplying by 1, which does not change the value of the fraction. So 8 times 5 is 40. Now, let's look at this denominator and compare it to this. What do I have to multiply this by to make it look like that? X squared, because x squared times x would give me that x cubed. So I have to multiply the top by x squared. So 1 times x squared is just x squared. So I have found the LCD. I've rewritten each fraction with the LCD. So I can keep the LCD, since I have the same denominators, and collect like terms, which in this case I don't. So I'm just going to have 40 minus x squared. That does not factor. It does not reduce. That's your answer. Let's look at this next one. Those are quite different looking denominators. We have binomials. So we have to find the LCD. You have to ask yourself, can you factor that? No. So that is a factor. Can you factor that? No. So that is a factor. So the LCD, remember, is one of every kind of factor in the denominators raised to the highest power, which in this case would just be 1. So that's my LCD. So I have to write each of these with that denominator. So I'm just going to give myself a little bit more room to do that. And I'm going to put those in parentheses. Now I'm going to write these with the new denominator, my least common denominator of x minus 1 times x plus 4. The order does not matter. You could write x plus 4 then x minus 1. Right, so as I look at the old denominator and I look at the new, what do I need to multiply by? X plus 4. And I have to do that to the top and bottom. And notice I need to distribute. So I have 3x plus 12. The next one, look at the old, compare to the new. What does it need? An x minus 1. And again, I need to distribute. So I have 6x minus 6. So again, I found the LCD. I rewrote both fractions with the LCD. Now I'm going to collect like terms across the top. So I have this denominator. X minus 1 times x plus 4. Now let's collect like terms. I have 3x plus 6x, which is 9x. I have 12 minus 6, which is positive 6. Then I'm going to look and see, can I reduce that? And again, by factoring. Well, I do see a GCF here of a 3. And that would leave me 2, no, not 2, but 3x plus 2 over this denominator. So I look at that and say, can I reduce? No. So could I have stopped there? Yes, that would be correct. But again, I factored it and looked and said, oh, there's nothing alike. So that's also okay to leave as an answer. This one's going to get tougher. 1, we have this minus sign that we're going to have to deal with, and 2, we don't have the same denominator. So let's deal with finding that LCD. Remember, the LCD comes from factoring the denominators. We cannot factor that, so that's a factor. We can't factor that, so that's a factor. So the LCD is one of every kind of factor raised to its highest power, which in this case would be the first power. Now I'm going to rewrite this so I just have a little bit more room to work with. So this is over x plus 3. I'm going to put those in parentheses, minus, and then I have here 3x minus 4. But I need to deal with that negative. What am I going to do? I'm going to distribute that negative. So I'm going to make this a plus sign, and I'm going to distribute that and make it negative x and positive 4. Think about subtracting as adding the opposite. So now I have a plus, a negative x, and a positive 4. The next step is rewriting both of these with the least common denominator. So let's go ahead and do that. Then we need to compare old to new. What do I need to multiply by? 3x minus 4. So I'm going to have to FOIL this out. First out, enter last. So I multiply and I get 9x squared minus 12x plus 3x minus 4. The next fraction, compare the old with the new. What do I need to multiply by? X plus 3. So I need to put all of that in parentheses times x plus 3, and again do that first out, enter last. Multiply, that's negative x squared, negative 3x, then plus 4x, and plus 12. So now since I have the same denominator, I can keep that denominator and collect like terms in the numerator. So 9x squared minus 1x squared is positive 8x squared. Then those combine to make a negative 9x, and those combine to make a positive 1x. So adding those together, I get a negative 8x. Then negative 4 and positive 12 is positive 8. So I've added. Can I reduce? Well, look at the top and they all have an 8, so it's just kind of screaming at me. Take out a GCF. So I'm going to take out the GCF of an 8. Then I look at this trinomial and ask myself, can I factor that further? Well, there's nothing that multiplies to get positive 1 and adds to get a negative 1. So that's a prime trinomial. So this would be the final answer. However, if you stopped here, that's also correct, but you really don't know that's correct until you factor it. Ooh, that looks a bit tougher, but at least I don't have a minus sign. But man, look at those denominators. Well, as I recall, to find the LCD, it says write down one of every kind of factor. So I need to factor those denominators. So let's just do it right underneath here. That's a pretty easy trinomial. What multiplies to get negative 4 and adds to get 3? A positive 4 and a negative 1. All right, let's factor this one. What multiplies to get negative 20 and adds to get negative 1? I think a negative 5 and a positive 4. So what would be my LCD? Remember, I have to write down one of every kind of factor. So I've got an x plus 4, an x minus 1, an x minus 5, but I've already written down x plus 4, so I've already got that factor, and they're all to the first power. So that is my least common denominator. Ugh. So again, I'm going to rewrite this to give myself a bit more room. Thank goodness that has a plus sign, so I don't have to worry about distributing that minus. And then I want to change these that have the LCD. Compare the old to the new. What do I need to multiply the old to make it match? An x minus 5. So again, I have to multiply all of that times x minus 5, which means I have to FOIL it out, F-O-I-L, first out, enter last. Okay, so let's do that. That's going to be 2x squared minus 10x minus 7x plus 35. Here, compare the old to the new, I need to multiply by x minus 1. So again, I'm foiling. Now I'm going to write down that denominator. And yes, I know that's long. And I'm going to collect like terms across the top. So 2x squared plus 1x squared is 3x squared. Then this makes negative 17x, and this is positive 30x. So combine those, and I believe I have a positive 13x. And I have 35 minus 31 is a positive 4. And you think, surely I am done. I have done all this work. Well, maybe, maybe not. That looks like that's a trinomial. I need to know if I can factor that trinomial. So let's see if I can factor it. And then if I factor it, could something reduce? That would be really great. So let's see, 3 and 1, so I know 3x times 1x. And you know, usually I would try 2 and 2, but I'm going to try the 4 and 1 because 4 times 3 is 12, which is really close to that 13. So I'm going to put the 4 here, and I'm kind of looking at that 4, and I'll put the 1 there, and it's all positives. I check that, and I do get 13x, so it does factor. And then I reduce common factors. So let's write out my final answer of, what do I have? 3x plus 1. And again, I'm just going to put it in parentheses to be safe, over x minus 1 times x minus 5. So here's a real good example that I didn't know if I could stop or not. I had to go ahead and try to factor that, and sure enough, it had a common factor, and that's my final answer. As I look at problem 5, again, I see some red flags. I need to make sure I distribute that minus. So I'm going to do that first thing. I'm going to change this to a plus and distribute that minus. All right, so it's going to make, I'm adding the opposite. Then I look and say, okay, I'm adding fractions. I need to find a common denominator. So I've got to factor those denominators. This one's a little bit tougher. 2x times x. Let's try 5 times 2 for 10. Well, I can't put the 2 with the 2, so let's try the 5 here and the 2 there. And let's see, that would be 5x. That's 4x. If I make them both negative, that gives me a negative 9x and a positive 10. So I think I factored that right. And then let's factor this one a little bit easier, a negative 2 and a negative 4. So that LCD is one of every kind of factor. Another long LCD. So let's see. We've got 3x minus 2 on top of this denominator. And it's nice to write it in factored form so you can kind of do that comparing. Plus a negative x minus 6. Let's just go ahead and put that all in parentheses. Okay, so we need to rewrite that with a common denominator. So I'm just going to write one big fraction. See if I can make this a little shorter. Not much. I'm not skipping many steps. All right, so again, I'm going to compare the old with the new and go, this needs an x minus 4, so I'm going to multiply by x minus 4. So let's go ahead and FOIL that out. And then look at this one, and that one needs a 2x minus 5. And again, I'm going to FOIL that out, being very careful. So I have a negative x times a positive 2x, which is a negative 2x squared. Then a positive 5x, a negative 12x, and a positive 30. So instead of making two separate fractions, just one big long one. All right, so now I can collect like terms. Again, writing that LCD. Okay, so 3x squared minus 2x squared is 1x squared. Then all of that is negative 14x. And all of that looks like negative 7x, which combines as negative 21x. Then 8 times 30 is 38. Does that factor? Well, the good news is there's a 1 in there. So I just have to say, is there anything that multiplies to get 38 but adds to get a negative 21? Well, let's see. I know 1 times 38, that doesn't work. But since 38's even, 2 times 19. Hey, negative 2 and negative 19. So that does indeed factor. So let's keep going. So I'm going to factor that as x minus 2 times x minus 19. And I kind of see that x minus 2 in the bottom. So I know that's going to reduce. So I want to now reduce and write down my final answer. And again, just being careful, putting everything in parentheses. So those last two problems are long. You just need to take your time and be careful